is a more professional system. Destination is important. Even in the Udupi region now, all the non-recyclables which are difficult to recycle go to cement kilns. There's a tie-up which the ULP, that is a municipal corporation, has. We've kind of looked at wet waste, we've looked at dry waste, and the next steps will be looking at composting of even the slaughterhouse waste, looking at a proper disposal system for sanitary waste. We really believe, I mean, India has this huge problem. We've been hearing it. I've been working 20 years with it, but I'm still convinced that decentralized systems bring about maximum resource recovery, and that's what we're looking to do. Thank you, and I look forward to some questions.
Thanks a lot, Vilma. Your audio was cutting in and out in between, but I think the combination of your voiceover and the slides really gave us a clear picture of the example at Udupi. Thank you for that. I have the privilege of now calling upon Mr. Austin. Mr. Austin is a senior advisor with IVL, the Swedish Environmental Research Institute. He's been a project leader for more than 100 national and 15 international environmental technology projects. And he was the vice president for IVL, the Swedish Environmental Institute, till April 2020. Please welcome Mr. Austin to the session.
Yes, thank you. I think I have a problem with sharing my PPT.
Maybe the CII colleagues can quickly check whether they have given the rights to Austin.
I have the right, but PPT has disappeared.
Here it is, I guess. Yep.
So, good morning, good afternoon. I will tell you, I would prefer to be in India. In Sweden, it's really cold now, and the coronavirus is spreading quickly. I will talk a bit about waste and wastewater management from a Swedish point of view. First, my institute, we are owned by the government 50% and industry 50%. We've been working for many years to be the bridge between the actual problem and the universities. And we have offices in Sweden, but now also in India. We opened our first office in Mumbai last year, and we are very happy to start working with India for wastewater and for waste. If you look at the waste, you should also think about that it is connected with what we call eco-governance. For a long time and even now, all the city planning is divided in different areas. So someone is responsible for waste, someone else for energy, the third one for traffic, the fourth for water and sewage. And when coming up with holistic solution, this is not very good. And looking at the climate change, you realize that you need a common goal for the city. So we started since many years ago to try that the mayor set up a goal for the whole city, and then the different sectors should cooperate much more. This means that the problem in one area can be a solution in another area. So I will give you a few examples. If you look at waste in Sweden, we have like 470 kilo per person a year. We have tried to lower it, but it goes very slowly. It follows the economy growth. Therefore, we decided in the 90s to get rid of landfill. Why? because most of the emission of carbon dioxide or climate change gases as methane comes from the landfill. And we have now lowered the amount going to landfill to 0.04%. It's very low. So what do we do with the other? First, we take away hazardous waste. And then we have more and more recycling. Nowadays, 35% it goes for recycling. So we have station where the citizen must sort out plastic, metal, glass, and newsprint and so on. And the recycling rate here is quite high. Of all the waste, 35% it goes like this. We want to increase it. The problem we have now with plastic is how to sort out different categories. But after doing that, we have also been working a lot with composting, but try to go away from it. So now the organic household waste in the future must be used to produce biogas, and by that minimizing the emission of methane gas. But on top of that, 50% of the waste is left. So we have installed in Sweden incineration of household waste. We have only 10 million inhabitants, but we have 41 incinerators spread over the country. So every large city, they have an incinerator. By doing that, we have been able to switch from using oil from heating and cooling to using district heating and district cooling. And we also produce electricity. The problem has been the dioxin, which is a severe problem. So therefore, in the end, mid-90s, we had to have a better equipment. And you see, after that, the dioxin emission has gone down dramatically. So now we have the incinerator in the middle of the city, and we don't need to be afraid of those emissions because of that. And I will stress that going around in India, people are very much afraid of this, and they should be. But there is solutions. And what I want to stress also from an Indian point of view is that the incineration you have only produce electricity. That is only 1/3 of the total energy content. 2/3 will be in the hot water. So please start to use the hot water with heat pumps for district cooling. Cooling is the fastest growing energy demand, and it will be higher, as you understand, from a climate change point of view. There is enormous resources that can be used for the cooling purpose, and by that also getting a better economy. We will introduce a more Nordic perspective, what we call zero waste city, where we have different companies doing the sorting of the waste. And then you need also the recycling. And you can never avoid that the citizen must be trained and having the understanding why you should sort out and how you then can recycle. And you need an industry that can survive on that. But we also have good experiences from the Nordic of introducing incineration of the waste and also taking care, as I said, of the both hot water and electricity. On the other hand, you should use more of the organic waste to produce biogas. And kitchen and restaurant is very good to start with. We now have an evaluation also in India, which of the substrate is the best to produce the biogas. And as you see, we have several Nordic companies in this sector that are willing to cooperate with India. But in the end of the day, you need a cooperation between Indian companies and Nordic companies for sure. But this is just to show you that it is possible to build up what I call a zero waste city. When we are discussing, we must also remember the problem with the water. So it's connected also with water stress. And you see in all India here is high stress, meaning that you are using 40 to 80% of the amount of water. This is spread quickly now. Even outside Sweden, we have problem with water shortage. So we have to rethink. And how we have been thinking for years is that the wastewater treatment plant should protect the environment. But at the same time, we realize that we have more components to take away. We start with organic, then phosphor, then nitrogen, now pharmaceutical residues. So I think if we think about the water we must rethink. So what we are developing now is a production facility where you see the wastewater as a resource so that water can be reused. The sludge produced should be used to produce energy, and you must recycle nutrients because growing up more people. So this is now implemented in full scale in some cities in Sweden. And we are also cooperating in a European network where they are studying different alternatives how to minimize the use of water. So if you have interest, you can go to the homepage. And on top of that, people are not convinced to drink wastewater that it's good. So we took the wastewater from Stockholm. We produced a beer from that called Purest. It was sold all over Sweden. If you go to YouTube, you have many followers. By doing this, we have analyzed the quality and we convinced that this could be a way forward. If the 2 billion people in the world not having drinkable water should produce that water in this way, or with reverse osmosis and the electricity produced from coal power plant, the emission will be 250 million ton higher. So it's preferable to have a more circular, both for waste and both for wastewater. Thank you, and go over my time.
Thanks a lot, Austin. I think a great example of how circular a city can really be if all the environmental aspects are seen together more holistically. I'll now call upon Yashas Band. Yashas is director with organic recycling, and he'll be speaking on what can be done and what should be done for technologies to be successful in India. Over to you, Yashas.
Good morning, everyone. Good afternoon, everyone. And thank you, Mr. Malik, for the introduction and allowing me to speak. May I ask the host to give me the share rights, please?
Sure.
So before I share, so I'm a second generation in this in the Indian waste sector. Have been involved in the developing of technologies over past 2 years, with my first generation being involved, and then I coming into the picture past one decade, I would say. And we have been focusing majorly on developing technologies with regards to treating of the organic fraction of the MSW. The journey has been, I would say, beautiful and. Just a minute, let me share.
Yes, we can see the presentation.
So going forward, so the thought process of this particular presentation was that more than talking about what technology we have or what we have done, I think the whole agenda of the program of going global was the objective. And to achieve that, I think nothing better than sharing our perspective on how we went through developing technologies, where India stands today, and how the technologies that have been developed, as Mr. Austin also explained beautifully, the whole concept of eco-governance and the circular economy, utilizing of different technologies. Even India can do that, but the requirement is adaptation of the same. So one of the major movement that we are seeing, and for a successful, solid waste management in India, is the integrated solid waste management. For any city, as as rightly mentioned, the eco governance is a key picture, is a key requirement, and collection, transportation, the processing of the organic waste, either through decentralized, centralized, the MRF for the co-processing plant for the inorganic fraction, and then finally the scientific landfill and capping. This has to be there. This has to be there 100% to ensure that we are sending less amount of waste to the ground and reducing the pressure that is there on the land parcel. On this particular part, I would like to say that there needs to be a combination of both when we talk about processing. There has to be a combination of decentralized processing for the organic fraction, because treating the waste at source, specifically organic waste, has a lot of advantages. As also mentioned by Ms. Wilma also, and the centralized facility should be focusing more on the MRF or on the co-processing plant from the financial point of view as well. So this is what the overall integrated we feel, and this is where the India is also moving forward. Going forward, the Indian waste sector past, I would say, since the time of the 10 years, have seen a lot of changes and a lot of advantages. A few of the advantages that we are working towards from all the stakeholders' point of view is, one is the implementation of the SWM 2016 rules, which define the rules and guidelines for each stakeholders, and as well as define the technologies, because it is very important that the right fraction of the waste gets treated with the right kind of technology, so that the process of the project being developed is financially as well as technically viable. Otherwise, certain times it happens that either you are too focused technically or you are too focused financially, and then eventually the failure happens because of the varying waste characteristic. The second is awareness, because of the whole Swachh Bharat mission. One of the challenge that we all as technology providers or as project developer had been facing is putting forward the right technology, and why it is important that biogas is a good solution at a large scale, at a scale above 5 tons, till up to 100 tons, 200, 500 tons, or 1,000 tons. The idea of incineration comes into the picture, but the organic fraction has to be treated in the right way. It had been before that the technology was more focused over incineration, where everything was put in a black box, and sometimes it still continues, unfortunately. But still, the awareness has happened. The stakeholders are much more aware on the technological part as well. They understand what kind of waste needs to be treated with what kind of technology, and what are the benefits behind that. There are, the government is pushing a lot of schemes into it. The CBG, the Satat scheme from biogas to CBG. So there's a push, there's a movement from, on the financial viability point of view, and obviously from the technical side, where the conversion losses are less when you go with the CBG or utilizing or cooking directly rather than converting it into power, has a lot of benefits from technical as well as financial point. The R&D part, a lot of activities on the private scale, the private institutions as well as the government level. There are so many schemes that are being running. There are so many advantages from the point of view that research and development has started happening in India, specifically with regards to waste processing and waste technology. There are a lot of small-time entrepreneurs. There are a lot of researchers, various the institutes that are there. Premium institutes like IITs and NITs have now, or CSR institutes have started focusing on waste and its fraction, and finding out technologies, new technologies, as well as developing or improving on the other technologies which have been previously present. Though the two, I would say, roadblock or the movement that we require in India for ensuring that the technology is, successful and its adaptation is successful, is one is on the waste data. There has been redundant and old data that has been available. We all need to understand one thing, that waste every month, or for that matter, every season in India changes. Its characteristic changes, its chemical as well as physical characteristics changes. And this is something that we have observed while running a large scale plant in Sholapur. Therefore, I think one of the solutions for that is that India needs to have centers within the universities, the state universities, and the corporates, the private institutes who are in the sector, the technology developer, the project developer, should extend that support, so that we have a year-long waste data with us, so that we can plan better, the technology provider, the project developers, for that matter, the owners, because now many projects are coming where the government or the urban local body are becoming owners of these projects themselves. They are ready to own these projects as well as the outputs. And all depends on the data, as in any industry does. The input data corresponds to your output data. So I think one is that. The second, I think, is the non-standardization. One of the challenges that we have been facing is, as mentioned by Mr. Austin, that when you talk about incineration, now nobody is against incineration in India. The only challenge that we face is definitely on the pollution control methodologies being deployed in these waste to energy plants based on thermal technologies. And second is the combination or complete MSW, the mixed MSW being put into the system for treatment. Therefore, I think there's a need for standardization. If the standardization in the sector comes in, the technologies can prevail, and you can also have organizations, definitely genuine organizations, serious organizations who can put forward definite performance guarantees on these technologies. And I think the government should implement, as for other industries like oil industries or automobile industries, we have certain standards and certain the ISO or the BIS standards. The same should be kept as a minimum requirement for these technologies being developed in India or coming from outside in India. So just to share with you all our experience on the two models. One is the centralized model and one is the decentralized model. So one of the major challenges I think that we faced in Sholapur was when we started way back in 2008 with the construction and with the activity. We started the small 50-ton plant over there to study the kind of waste that comes in. While we were studying that, over a period of 6 months, we had an idea. We established our plant, it happened. And over the period, since the time we have been operating since 2013, it has been a learning curve. There are times when you only get, the waste from slaughterhouses, more of protein, more of meat. And there are months where you don't get this kind of waste, but you get more of bitter leaves or plantation or high lignocellulosic material. So your mechanical equipments also get, damaged. They are not used to these conditions. Or for that matter, biogas, as you all are aware, uh, is easy, but it is very critical to manage. So over the years, we have been able to manage and develop a technology, and we have been able to adapt. One of the success reasons for us have been that we have been able to adapt to the local conditions with regards to the water requirements. So we went with high solid dilution. We came to know that the temperature keeps on falling, keeps on rising in a city like Sholapur. So the whole idea was to have a thermophilic so that we have reduced land. And the most important, I think, that we have been able to achieve is that we have been able to achieve the co-digestion, because the Indian waste quality varies so much that we are now very confident on what total solid or volatile solid content, what kind of gas can be produced, and what kind of input can be done. And I think another challenge was the vendor development, because this whole plant of a 400 TPD plant was developed in India, except for the engines and the balloons that were not present during at that time. While developing over here, because again, as for any industry, the input material has a specific characteristic, so it is a bit easier to design systems and technologies or machineries for the input and the output. Waste being, the MSW being very heterogeneous, you need very robust, you need data. And over the period of 10 years, we have been able to have those data. And that's why we have been pushing that everyone needs to, or at least the government, should start focusing more on the data. Because if you want to run this as more of an industry and bring this sector into an industry status for technology and projects to be successful, the input data is very important. So we have been able to adapt to the local conditions, and wherever part of the city, whichever parts of the state in India go, the first thing that we do is adapting it to the local conditions. And that has been the reason of the success. The second point was on the decentralized, where we have been able to achieve the descale the whole technology so as to ensure that the treatment happens at source. But as it goes, there is non-standardization. When I say one of the major challenges with non-standardization is that there are systems and projects available at a very with no standards, with no shelf life, and the only agenda is to put a system or put a plan which runs for 5 years, 2 years, and then you go ahead. So that was something that we've been able to develop, and the technology, or from the side of one challenge that we have faced in the decentralized is the power distribution, which we have been able to overcome now with the integration of the solar rooftop. Still, there are 10 to 15% losses. Now we are moving towards a target where the focus is using refrigeration for these decentralized. So the point is that we need to have different models, different decentralized model as per the locations. Somewhere the biogas or power is required. Somewhere it might be, as again quoting Mr. Austin, that somewhere water is something from the incineration that is untapped. Similarly, in decentralized space, utilizing biogas for refrigeration or for any other purpose for heating is another option that has been untapped, and that has to go on now, going ahead. Few of the responsibilities that I feel for technology adaptation in India from the urban local bodies or the technology provider, the project developers, is that from the ULB.
Yes, yes. I'll have to request you to close, please.
Yeah, so I'll just take a minute more. So this is what the whole idea is that ULB needs to enforce the SWM 2016 rules, which is very important, and start evaluating the technical side of it. The focus is that we adapt to the local conditions. And last, I think the need for the need to go local is that the technologies that are available from outside and the Indian technology partners or the project developers needs to come together, develop the technology within India with the experience from the European or the Southeast Asian countries that have been successful from the developed countries. And when you're coming into the when you're going global, both the parties need to have a long-term strategic vision. It cannot be a vision for just 3 years, 4 years, but it needs to be a 10 years, because when you're talking about waste, it's a long, as in the terms of governance, when we talk about the planning is at least for 20 years and 50 years. So I think that this is where I would like to close, so that we can all come together and hope that we can manage waste responsibly.
Thank you so much. I think a lot of breadth in that presentation. Let's quickly go on to Michael. Michael Rada is the founder for Industry 5.0, and we'll talk about